Hi, everyone, and welcome to Discovery's Chats with Changemakers, our last one for this school year. I'm your host, Tiffany, and I'm an 11th grader in Texas. I participated in Discovery's Future City competition when I was in middle school. Each month, I welcome a different guest from the engineering community. Today, I'm chatting with Michael Pearse. Michael is a software quality engineer and a member of IEEE-USA, which is the Institute of Electrical and Electronics Engineers. Michael, welcome. We're so excited for you to join us today.
Thank you. Thanks so much. Very exciting to be here. Thanks so much, Tiffany.
I'm going to ask Michael a few questions to get to know a little more about him. You can ask questions too by typing in your question in the Q&A box below, and we'll save time to answer as many as we can. So, Michael, can you tell us about the company you work for and what you do there?
Yes, definitely. Hi, everyone. Once again, my name is Michael Pearse. I currently work at the corporate office of Foot Locker as a senior software quality engineer. Now, you guys must have heard of Foot Locker, where you get those nice sneakers. Yes, that's where I work at the corporate office. Basically, what I do is ensuring that the IT service management part of things in the background are working as expected. So I'm excited again to be with you guys today.
So what exactly does a software quality engineer do?
You know, that's a good question. A software quality engineer like me, we work to monitor every part, every phase of the software development lifecycle. And this is to ensure the design quality and making sure that the software adheres to the standard set by the stakeholder, which includes making sure that the new products work before they're released to the public. So in the software development life cycle, we have to make sure the requirements are there, analyze it, make sure the design is as expected, test the code, and also make sure that the product is fit for use. It's like remembering when you have your iPhone or your new toy or something like that, and you press the on button. Imagine after pressing that and it doesn't work. Yes, that's what folks like me do, making sure those things work like they should work.
Awesome. So you mentioned testing code. So how do you test the code?
Well, so there are different ways to do it. In software quality, that's the tricky thing. It's not just testing the code. We're also assuring the quality in the whole process. As a matter of fact, testing the code is the phase before it gets to UAT, that's user acceptance testing. To test the codes, you definitely have to know about code yourself, right? So there are many tools we use, to test the code. Sometimes we have to run it through load testing, and sometimes we have to automate it, like using tools like Selenium. That's part of the testing tools to test the codes. Now, you're not just testing code, you're also testing to make sure that those codes do what the requirement says they should do. And that takes a whole lot of, we call it happy path, to make sure that, this code is meant to open this door. Okay, it opens the door. But there's another path where you have to ensure, it's called the negative path, that, okay, well, what if the person goes behind, just thinking different ways in being able to, to make sure that the code is solid. And that's just the typical way we test these codes.
Okay, so how do you know when software is ready for production?
That's a good question. Now, there are two ways to know. First, the software itself as a product has to meet the requirement. So when a product is being developed, there are requirements that the developer has to build to make sure that it meets, it does what the stakeholders want it to do. So you must test that to make sure that all parts of the requirements that the stakeholder wants is implemented and working as it's expected. That's the one way to test that, so you make sure all the requirement is complete. Now, another criteria, and this is the very important part in making sure a product is ready for production, is making sure that it is also fit for use. Now, check this out. So the first part is saying, oh, this product has been built to fit a requirement. But as a quality engineer, quality assurer, you must also ensure that that product is fit for use. For example, a stakeholder may say, hey, can you build me a toy that moves? Okay, the developer goes ahead and builds a toy that moves. Now, when you get the toy as a final product and you're trying to move it and you're finding out that this toy only moves backwards, it's not moving forward, right? If you think about it from a requirement perspective, that product itself has met the requirement because it moves. but we also have to make sure that it is fit for use. So it's not just moving backwards, you want the product to also move forward. So those are the two very important criteria to check for before a product is ready for production. It must be built to fit and it must be fit for use.
Okay, testing must be a very important process then, because I bet one wrong software bug or something that goes wrong could really hurt the business.
Yes, this is true. Yes.
So do you use artificial intelligence when testing your software?
No, so not yet. No, we're going to get to that. Now, you made mention testing being a very critical part. Imagine, for example, you're in your plane, right? And while in mid-air, the pilot just says something like, oh, well, we're actually facing some turbulence now, but actually we forgot to test. We forgot to test the softwares in the plane. Everybody will be scared, right? Or we forgot to test that, the seat buckles were old, everybody will be scared, right? This is the importance of testing. And you can see the damages it can do, when it's not properly tested. Now, artificial intelligence, those are coming true. For now, I don't use that yet, but it's on its way. But I can let you know that in testing, there's a whole lot of automation that goes into it. Now, the automation also has to play a part in the return on the investment, because there are times where it's just easier to easily manually test it and make sure it's fine. But most times, 80% of the time, you want to automate it. So artificial intelligence is something that we know, from AI to machine language. Those are coming in very, very soon at a very faster rate. Now, also remember, the artificial intelligence itself feeds off the intelligence from us, right? So the better we are with doing the automation and make sure the manual part works okay, the better the artificial intelligence does as well. And an example of that, real quick, for the audience, an example of an artificial intelligence platform coming into play is Functionalize. That's the name. It's an intelligent testing platform that is being used now, in development as well.
I bet that automation really makes everything way more efficient in your job.
Totally, yes.
So could you tell us about your educational background and what degrees you've earned?
Yes. So my first degree was in mathematics. Yes, mathematics, I can tell you, it was crazy. But that definitely exposed my mind to the value of being able to think from an abstract perspective. Now, interestingly, mathematics is not so much about numbers, especially when you go into the graduate studies of it. It's really more about abstract, more of like helping you think broadly. And after doing my mathematics, then I went to the graduate understanding of business. In my experience, and those were very helpful. You also have to, especially if you're in the testing field, you also have to understand from a business perspective of things. And because these are the things that make you know that this is why customers has to be in the center. This is why contents are important, and after doing my graduate understanding in business, I also did a graduate understanding in information technology. Well, the reason for me was, I knew that I did not really want to be a software developer. Neither do I want to be totally in business. So I wanted a middle spot there, that fits perfectly for me. So that's one of the reasons I went and, did the graduate studies in information technology as well, a master's. Now, after that, I also went into to do a quick understanding of cybersecurity. And I'm sure that's the term most of us are used to. Now, the reason I did that was just being proactive. You see, if you're in quality assurance, software quality assurance, it's easy to see that this is where things will progress to, because you're the gatekeeper, making sure the software is working well. Well, because the cybersecurity is a concern now, you might as well also make sure that works well also includes that it doesn't have vulnerabilities in it. So an example may be that, when the software was developed, there weren't a check on the input fields. So those are the things you begin to have in mind. And I should say, though, my studies is not so much about career. It was just sheer interest that got me doing all those studies, I tell you.
So we have our first audience question. Davion wants to know what your favorite thing is about your job.
I like that question. Let me tell you, man, my favorite thing is being able to break the code. Yes, I can tell you, I can tell you my day is not awesome yet until I'm able to break the code. So I got to tell you, there are developers out there that are very, very good with what they do. Their codes are hairtight. What it means is there are no issue. You can't find issues with it. It works exactly like it should work. But if you're a tester, what gets you excited is being able to think outside the box. So you're thinking from a very different perspective, and you're trying to find a way to break that code. Let me tell you why that is important. So for example, think about spaceships that go into space and things like that. You must be able to find where the issues are, because you don't want to be meddling around with things breaking in space. That can be very fatal. So my day is exciting once I'm able to find a bug in the code and like, yeah, I did it. And of course, the developers, they do always like to hear that. But yeah, that's my favorite part.
So you write code to break code?
Mm-hmm, mm-hmm.
Very cool.
There are times you have to do that. That's where the automation part comes into play. But remember, it's not just writing the code. It's really about the thoughts first. So if you develop if your software, what it does is to open the door. My writing the code to break that code is to find out what happens. We call it like boundary values, when the door is not totally open or it's not totally closed. Why? Because from experience, this is where developers usually, they forgot to think about that. So let's say the input field or the margin is meant to be between 1 and 5. What if I put 5.1? What if I put 1.2? Those little things. So that's where the scripting part comes into play, feeding off your thoughts about being able to think totally different, away from the typical box. Mm-hmm.
Awesome. So what types of engineers do you work with?
In the testing industry, in the development operations aspect of things, we have the software developers. We have the architects, because usually, remember, the software developers, they're developing the product itself in software. We have the architects who has to work with configurations as well. Then we also have the database managers, database engineers as well, who, the software oftentimes have to feed up data, who work with that as well. Then, aside from those three main category of people that I work with from an engineering perspective, we also have actually requirement engineers, as it were, and also business analysts and the project managers. So those four, in the typical sense of the industry, the folks I work with all the time from an engineering perspective.
That's cool that you get to work with so many different people to make a final product.
Yes.
So,
and another interesting thing about it is sometimes when you're working with with the team, they're not always, especially with what we are now, they're not always located in the same place. Some might be in different parts of the world. So, and that's why as an engineer, in everything you do, being able to work with people is also critical to being able to do your job very well.
For sure. Mm-hmm. So in what ways do you think your job encourages you to be a change maker?
I like that. I like that. So in my experience, especially being with the IEEE, that I've been there for so many years now, I see technology, and my experience working with kids, they're very creative, very, very creative. I give you an example real quick. There was a robotics challenge we did the other day, some time ago at Penn State, Harrisburg. And we had a challenge for them to move a robot past this very narrow path. And there was this kid, he programmed the robot in such a way that it bypassed all the checks that we had in place. Very, very creative, and of course, you earn extra points for doing that. Now, when you have done that so many times and you work with kids so many times and you see the way they think creatively, what excites you is being able to put this technology in their hands. So for me, I haven't been in the software industry in engineering as well, I look forward to just being able to put these tools in the hands of the kids and just let them go away and do all this extra stuff, all this exciting stuff, because, the creativity for them is the same thing that happens when they, they play pretend. So it's like saying, oh, I just don't want you to play pretend. Here is a tool for you, a technology to go ahead and see what you can do with it. So that gets me excited in just being able to make that change, knowing that these kids, there's a whole lot they can do.
That's awesome. So you mentioned that you're a member of IEEE. So can you tell me about your involvement with them and why it's important to you?
Yes. I've been with the IEEE for over 13 years now. And just by my nature, even when I was in London, I've always been interested in being able to volunteer and give back. It's just been a part of me. And also being in the STEM industry, I wanted to be able to give back technology, sincerely speaking. Now, the IEEE gave me the platform to do that. And that's why I wasn't just a member for 13 years. I've been an active member, which means I'm always involved in every event, that has to go to places, get technology in front of kids and do all those things. So IEEE gives me the opportunity to do that, and apart from that, there's also the opportunity to learn. You meet friends, a whole lot of friends that I've had now for so many years. I've met them from the IEEE. Now, not just friends, but also peers as well. So these are the values I gained from the IEEE. Not too long ago, about a couple of days ago, I was involved as a virtual judge in the Baltimore Robotics Challenge. And we've been doing this for over 15 years, and when you come to an environment like that, you see kids up, a whole place filled with so many people, doing all these challenges and the technology part of things. So that, as it is the excitement I get being an IEEE member, and importantly, just being the avenue for me to be able to give back and volunteer, is one thing that I can tell you that excites me with the IEEE.
That's awesome. And sounds like a neat organization. And it's so cool that you're able to help kids get these opportunities in the STEM field, and something that you're passionate about. So what strengths do you have that make you a good engineer?
In my experience, I can tell you, yes, you want to know all the standards, you want to know all the technology, but you also must be able to think creatively. If there's anything I've learned, with respect to being good at what you do, is being able to think creatively. And I think that's one of the strengths I have, in what I do. Again, so you can imagine as a software quality engineer, you're trying to break things. Well, break it for the good. When you're trying to break things, you have to think outside the box. You have to think from a very, very different perspective, especially when I also used to work at back then at Deloitte and IMARC. So when you're dealing with complex systems that has a lot of integration points to it, your thinking must be at a very high level with respect to creativity and also ideas. So I will say that's one strength that every engineer needs to have. And of course, being able to think about things, the thinking faculty, in my experience, is the one thing that strengthens you more. So you're not just seeing things from the facial value. You also take time to think about it. Like when we begin writing testing scripts, for each test script we write, there are like two different paths: the happy path, the negative path as well. So, and the negative path is not derived from the requirement document. The negative path is derived from you being able to think outside. So you can imagine doing that over and over and over again and automating that. It builds a lot of your creative thinking, just to be able to think outside the normal channel. So that's one strength I will say that I do have in that field.
Yeah, I could see how creativity, and you mentioned earlier communication are very important. So what would you tell kids who aren't so sure about engineering, or who maybe think that they're not cut out to be an engineer?
Let me tell you, you can. Let me tell you, don't even listen to anybody thinking and saying that you're not cut out to be an engineer. What I can tell you is, as long as you've been able to, while you were younger, to play pretend, as long as you've been able to, create things and all that, the engineering term really is just really to, in my opinion, just to put a formality to it. Do not believe that. Give it a trial. I would say that. Give it a trial. And yes, and not everybody will be an engineer. But give it a trial. Find a mentor or a peer. And of course, like I said, use the power of play, pretend, and importantly, explore it. Discover it. Like the Baltimore Robotics Challenge I just told you about that we had not too long. We had a kid there who that was his first time being involved in that. And one of the things he told us was, because we asked them, okay, so tell us about your challenges and your experience in doing this. And he said he never knew that, engineering or doing things like this, because what they had to do was build a robot that worked on two legs. And while doing that, remember, they were working remotely sometimes. And also they have to put a whole lot of things into play. For example, when the robot is working on two legs, one of the things you have to think about is friction. So if the floor that it's walking on is slippery, you have to think of putting something on that leg to make it hold faster, right? To reduce the friction. So he was telling us that he never thought about things like that. But by doing things like this, by trying it, by just, hey, let me give it a shot, he learned a lot from perspective of, oh, now as an engineer, you have to look beyond what you normally see and just think, think through things, from an environmental perspective. For example, if the slope, if the floor was, there's a slope in it, then it takes on a different thinking perspective as well. So that's what I would tell kids, give it a trial, find a mentor, use the power of play, pretend, just try it, but don't think you're cut out not to be an engineer. Believe me, you are. I know you can.
That's great advice. So we have a fun question for you. If you could have any superpower, what would you choose and why?
Why wouldn't I want to be a Superman? Let me tell you, if I have a superpower, I would want every kid all over the world to be an engineer. Yeah. But of course, it doesn't always work that way, right? It's not often possible and practical, because at the end of the day, that's why, there's STEM, there's also STEAM, so science, technology, engineering, arts, and mathematics. At the end of the day, we still want those who can manage projects very well. We still want those who can sing good songs. We still want those who can, diverse skills, as it were, right? So even when we did the Baltimore Robotics Challenge, or any robotics challenge you do, you will find out that it's not just engineering that is tucked into it. You'll find out that, some people are just very good with designing things, just making the robot look so great, which they score points off of. And so the point is, while I would love for every kid to be an engineer, it's not always practical, but I will love, with my superpower, to make sure that every kid has some exposure to engineering. That way it can complement any other thing they do. Because in my experience, I can tell you, the thinking that way adds a lot of value to every other thing you do, in my experience. So that's the secret to my superpower and what I'm going to do with it.
That's a great superpower.
Thank you.
So we have our final question. What do you do when you're not at work? What are your hobbies and interests?
Yes. Now, unfortunately, when I'm not at work, I'm still in front of the computer. Yes. When I'm not working, doing, writing test scripts and writing test cases and, thinking about the design, setting up the environment and all that, I love graphic design. I love that. Why? Because I also take pictures as well. I, go out, take photography, pictures, design the pictures. But while I spend like 30% taking the pictures, I spend like 70% of the time, editing the pictures. That's what I have the passion for. So when I'm not at work doing test cases, I'm there taking pictures with with my camera and going back home and doing some graphic design on it. Just the other day, I was watching an Adobe seminar and how you can use Substance in 3D, that takes on a different perspective on its own, so those are the things that excites me, that I love to do as well. Now, one more thing I also do when I'm not at work is I have 3 beautiful kids and they get me busy. Ooh, yeah, they get me busy, I gotta tell you.
Well, that sounds like a lot of fun.
Yeah, it is a lot of fun.
Well, I believe that's all the questions we have time for today. Thank you, Michael, for joining us today.
Thank you. Nice having you. Thank you.
And thanks to all of you for tuning in for our season finale. Chats with Changemakers will be back in the fall with more episodes and more engineers. In the meantime, check out any episodes you missed. Go to discovery.org, click on the Engage section, and find 22 episodes to enjoy on demand. Hope you have a great summer. See you in the fall for more live chats.